Hello dear students of plus 2 medical and non-medical. So today I am going to discuss very important topic, torque and electrostatic potential energy stored in a dipole. Now first of all we have derived expression for torque experienced by an electric dipole placed in a uniform electric field. Suppose E is the electric field shown by these parallel straight lines acting from left to right. Let AB be the electric dipole placed in this uniform electric field. Let minus Q charge lies at A plus Q charge lies at B. Let P is equal to electric dipole moment. P is equal to electric dipole moment which always acts along the line joining the minus Q to plus Q charge. Let theta is equal to angle between electric dipole moment P and electric field E. Since any point charge Q when placed in an electric field will experience electrostatic force given by F is equal to QE. Therefore, this minus Q charge will experience force minus QE in the direction opposite to electric field. This plus Q charge will experience force plus QE in the direction directed along electric field. So these two forces minus QE and plus QE are equal, unlike and parallel, and hence they form a couple, because two equal, unlike and parallel forces always form a couple, and the moment of couple is called torque. It means this dipole will experience a torque, and this torque is given by product of magnitude of either force, that is QE, and perpendicular distance between these two forces. Now from this diagram we can see AN is the perpendicular distance between minus Q and plus QE. Then from this right angle triangle AN upon AB is equal to sine theta, perpendicular over hypotenuse, because this angle theta, this angle is also theta. This implies AN is equal to AB sine theta is equal to 2L sine theta, because AB is equal to 2L, length of the dipole. Therefore tau is given by Q into E into 2L sine theta, or Q into 2L is equal to P, so it is PE sine theta. So torque is equal to PE sine theta, which is the required expression for torque acting upon a dipole placed in a uniform electric field. In vector form, it can be written as tau is equal to P cross E. Direction is given by right-handed screw rule or right-hand thumb rule. So it means P is this, E is this. So direction will be like this. It means what will the effect of electric field on dipole? Electric field will always tend to align the dipole in its own direction. Electric field will always tend to align the dipole in its own direction. So it means if we have to rotate the dipole through some angle, work has to be done. So if theta is equal to 0, tau is equal to 0. Theta is equal to 90, tau is equal to maximum. It means when dipole lies along the direction of electric field, that is angle between P and E is 0, then torque is 0, minimum. And when theta is equal to 90 degree, dipole lies perpendicular to electric field, then torque is equal to maximum. Now, from same diagram we can find expression for electrostatic potential energy stored in the dipole. We have proved that when theta is the angle between P and E, torque is given by PE sin theta. PE sin theta. Now, if we have to rotate the dipole through some angle theta, work has to be done. And that work done is stored in the dipole as its electrostatic potential energy. Suppose this dipole is further rotated through small angle d theta, then small amount of work done is given by tau is equal to dw equal to tau d theta, or dw is equal to, or total work done you can say integral tau d theta, limits theta 1 to theta 2, any two limits, or w is equal to substitute value of tau PE constant can be taken outside integration theta 1 to theta 2 tau d theta PE sin theta d theta. Now what is integral of sin theta? It is minus cos theta, theta 1 to, or w is equal to minus PE upper limit cos theta 2 minus, for theta is equal to lower limit cos theta 1. So this gives the amount of work done in rotating the dipole from angle theta 1 to theta 2. Now let theta 1 is equal to 90 degree, theta 2 is equal to theta. Then this work done is known as electrostatic potential energy, minus PE cos theta minus cos 90 0, or U is equal to minus PE cos theta, or it is minus P dot E in vector form. Number 3. So it means electrostatic potential energy is gained by minus PE cos theta, or it is the dot product of electric dipole moment and electric field. Torque is the cross product of electric dipole moment and electric field. So when theta is equal to 0, when theta is equal to 0, cos 0 is equal to 1. So potential energy will be equal to minus PE. When theta is equal to 180, cos 180 is equal to minus 1. So minus 1 is plus. So U will be equal to plus PE. It means energy stored varies from minus PE to plus PE. When angle between P and E is 0, then potential energy is minus PE, that is minimum. So it is a stable state. When theta is equal to 180, potential energy is plus PE, which is maximum. So dipole will be unstable. It means amount of work done in rotating the dipole through 180 degree will be given by W is equal to final kinetic energy, final potential energy minus initial potential energy. So plus PE minus PE, that is 2 PE. It means question may be asked that what is the amount of work done in rotating the dipole through 180 degree. So it will be final potential energy minus initial potential energy, which is plus PE final minus PE. So it will be 2 PE. So twice the product of electric dipole moment and electric field work has to be done in order to rotate the dipole through 180 degree. So this is all about torque and electrostatic potential energy. So in the next video, I will discuss a few more topics, some questions regarding this electrostatics. So